Matthew and Robert, Elisa, just these parts of the class. Please be quiet.
I will.
Thanks. Now.
Open?
Okay.
That one, there's a window. There's no thing in the window.
Getting so hot in here.
Put it down, put it hard. How do I open a window?
Oh. So good. Okay, guys. Now, let's get a sample.
Okay.
In the second class, going to teach you about quadratic.
No, just basic algebra. Okay, now. It's okay. Yeah. Let me see how the coding is going on. Okay, now. Guys, the thing that we plan to do today is this, that, let me take this. Okay, I hope everyone has your handouts, you have your pencil, you have also your, and here words, Lucas and Elisa.
No, we're just talking about math.
Yes, please, keep the words, your discussion while we work together. Okay. Okay, now, guys, please, everyone has a pencil and highlight it in case if you have any questions. The handouts that you have is essentially the roadmap just for today, and along with it, I just need you enough exercises. Okay, now, for the second part of the class, before we go to our summative test, we are going to talk about the rational expressions.
Is that the title?
That's right. The rational expression I follow closely for the content of the course on this handout. Then you'll have the chance when you go back home to review this, and I give you enough exercises. Now, a couple of sessions ago, we started to talk about polynomials. We started to talk about the polynomial, and we said that if I have a polynomial, I can call it P of X, which P stands, my friend at the back. We said that the polynomial, P of X, P stands for polynomial, is a kind of the algebraic expression that we say that if we have a polynomial, we can just divide them together and create, for example, I have polynomial P of X and Q of X, and I can create another function, I call that R of X, which R of X is simply two polynomials, which they are divided by themselves. And that's the basic definition of a rational expression. When we talk about the rational expression, for example, you can, as an example, I can just define this function. I say P of X, let's call it F of X, not to confuse with the numerator. I say F of X, for example, this expression. One polynomial on the top, for example, I have X squared plus 2X minus 1 over X. X plus 1. Look at this one. This is again based on the definition that we have talked, and based on the thing which also, if you refer back to this, on this handout, you see this is a polynomial. It is a rational expression. Why? Because I first of all make sure that both the numerators and denominators are polynomials. Then as a result, then I can say that F of X is a rational expression. Look at this. I have started with a polynomial with a decreasing coefficients. For example, the power 2, power 1, and this is power 0, and also the same thing. However, if I say, for example, F of X is a function like this, square root of X over X plus 1, my question to you is that, is this a rational expression or not?
No.
Why?
It's not a polynomial.
That's, I want to say that's so true. As usual, This one is not a rational expression because based on the definition that we just discussed, the numerator is not a polynomial. It is just, if you just want to rewrite this, you can write x to the power 1 over 2 over x plus 1. The numerator, as you can see, this is not a polynomial.
What's a polynomial again?
Polynomial is any function that this is the sum of all the x's, that their power is a natural number.
It has to be a real number. It can be negative, positive.
No, n has to be a natural, for example, 1, 2, 3 goes all the way.
And then you use fractions like 3.5.
As a coefficient, yes, but not as a power.
The first one is
Guys, I said that please just write your notes. Yes,
no, just like that. So the first one is a polynomial because it's x squared.
that's right.
This is 2.
Any numbers which they are natural numbers, for example, 2, 3, 5, 7, 9, 100, but 1 over 2 is not a natural number.
Oh.
Then that's why. That's why this is this one that we say that this is a rational expression. This is the first thing, and also if you look at your handout, you see some little examples on the first page. For example, 5 over x. Please take a look in your handout that you have some more examples of the rational expressions. You have, for example, 5 over x is a rational expression. 2y plus 1 over y squared minus 4y plus 3 is a rational expression. And the rest, for example, a over a plus 10. These are all rational expressions. Now, before we just move on to do some very exciting stuff with these rational expressions, I want to say that based on the things that you learned, any rational expression can be mapped. What do I mean? For example, if you have these two sets, and this one is a bridge connecting these two sets by this function. We say that this one is x squared plus 2x minus 1 over x plus 1. Then you see that if you put any numbers inside this set, you can transfer this into a numerical value. For example, if I put 0 in here, I just want to see what number is going to be mapped. Then I put 0 inside. If this is going to be p of x, then p of 0, that's right, becomes 0 to the power 2, becomes 0. Plus 2 times 0, again is 0, minus 1 over 0 plus 1. Then you see it becomes minus 1 over plus 1, which is minus 1. Then you see that from 0, we can map it to the number minus 1. If you put, for example, f of 2, if you have a number which is 2 here, then you simply put in that expression. It means that anywhere you see x, you remove it, then you substitute 2 in there. Then, for example, if you put 2, becomes 2 to the power 2, plus 2 to the power 2, minus 1 over 2 plus 1. You get 2 to the power 2, how much do you get? 4 plus 4 minus 1 over 3. I have 8 minus 1, 7 over 3. Then it means that from the number 2, you map it into number 7 over 3. The thing that we did today, right now, when we have a rational expression, you plug a value in there to find its corresponding value. It means that we evaluated the rational function.
But that was, those answers are, never mind. No, never mind.
Here, say it.
No.
Are you sure?
Yes.
Okay. Now, guys, also in the page 1, on the first page of your handout, there are some more examples of evaluating a rational expression. For example, the rational expression which they have defined is this. I call this rational expression P of x is x minus 2 over x plus 3. And now in the sets that you have, you try to find this value. P of, for example, 1, P of 2, and let's say P of minus 1. Now, I just want to ask you, please, take maybe 2 minutes to do this, to find the numerical values of each rational expression.
Just to plug in the numbers?
That's right. Just plug in the numbers, and you can compare your result with the numbers which is in your handout. You see, I'm gonna prove to you the second summative test is gonna be, oh my god, the easiest test you have ever done. You can simply lean back, close your eyes, and do the test. It's gonna be very easier compared to the first summative test. Yes, Ella? It's gonna be easy. Yeah. Yes. You're done? Yeah, sure. Awesome. It's something very easy to do. It's easy for you, see that? How about you, Daphne? Awesome. I have not seen working before, huh? Okay. You done?
Yeah.
You can also check the answers in the handout.
Are you all correct?
Yeah,
And
yeah.
do example
Everything, how about you?
two.
Let's this is easy, huh? What is this? How about you? Fine?
Yeah.
Because you know everyone has seen that. You see, this one is a very easy answer. Now, before you forget, I'm just going to ask you, now that you have done this, from here, come to find the p-value of minus 3. How much is that going to be?
Undefined.
Undefined. Why it's going to be undefined? Because that's right, because when you put minus 3 in that expression, you get minus 3 minus 2 over minus 3, guys, be quiet, please. Which you get minus 5 over 0, which you know that from the things that we talked also before, anything which takes your expression to take form like that, a number divided by 0, you have to cry. You have to scream and run away. Because this thing is not going to be defined.
Why?
In the math, they say that if there are two things actually that when
you divide by 0, how many you have? There's no cookie.
listen. Guys, please listen. In the math, there are two numbers. Guys, please everyone focus. Focus. In the math, there are two numbers that when you just get that from the rational expressions, you have to really run away from this. The first one is that there are two numbers. Once you get a number divided by 0, they say that this is undefined, and the other one is 0 over 0. When you just go to the calculus course, in the higher years, you see that you can just resolve these two issues. Now, this is not our focus. Now I'm just going back to the same thing that I had before. Now, when we just have a rational expression like this, now we come to define a term which is called the domain of the rational expression. The domain of the rational expression, these are all the numbers that makes your rational expression to be valid, except the ones that take the denominator becomes 0. For example, look at this one. We said that if I just put x equal to minus 3, the denominator becomes 0. If I put x equal to minus 3, then I have anything on the top. then I have minus 3 plus 3 becomes 0. And that's going to cause a problem. Then what do I have to do? I have to exclude minus 3 from the numbers, which you can plug it into the P of x. How to exclude that? I'm just going to say like this. I'm going to say the domain of this function I'm going to say, I think just maybe that's the time, the first time you're going to see that. This is going to call the domain. It's all the numbers that is valid for P of x. I write it like this. I say the domain, and with the learn, I call it P of x. Means that the domain, which belongs to the rational expression P of x, and I say that these are all the x's which belong to all the real numbers. However, then I just want to say, however, I just draw this line. However, x cannot be equal to minus 3. Yes.
So to do this, so if, for example, on the book says result with the denominator x minus 3, you just flip the sign and then just flip it.
That's right. And you have to solve, there is one, I'm going to go there, it says the algorithm. I'm going to tell you what happens. Now, everyone is okay with this example so far?
Yeah.
Yes.
So does this straight line mean except not okay?
So,
It means however.
oh, the student is however.
Right there.
Okay. Now, let me just answer Lucan's ask. I'm just going to give you one algorithm which it makes the solutions much easier. Let me, yes, Ella.
How do you know if minus equals one of the numbers that you like? How do you know?
That's what we're going to talk right now. There's an algorithm how to find that number. And now the thing that we just want to discuss is that how to find this number minus 3.
What
Now,
do you mean by minus 3?
I need a number that you have to exclude that from your polynomials.
Oh, like we just don't want minus 3.
That's right. Because you may just
Get
have...
out.
Okay, now you're
Okay, now. Okay, guys, now, I just want to explain the algorithm which I have written here for you, but I'm going to do this by an example. Ella asked, how do I know I have to exclude one number from that rational expression? And that's the thing that we just want to talk. How to find this? There are a two-step method. For example, I have given you this rational expression. This rational expression, it's a valid rational expression because both the numerators and the denominators, they are polynomials. That's the first step. Now, when you have a rational expression for your summative tests, for your quizzes, Sabrina, and for many other things that you want to do, the first thing that you do is this. For example, I say to you, for example, hi Matthew.
hello.
And I give you this rational expression. You, without doing anything, you close your eyes and check the denominator.
Equals to 0.
That's right. You check the denominator. Listen, please guys, listen. I explain. Just please, if you come with a question, write it on that piece of paper which you have, then I come later to answer that. Now, I just give Matthew this rational expression, and Matthew, without asking anything, closes his eyes and says, okay, I'm just going to take the denominator and equate it to 0. My denominator is how? What is my denominator? That's right, 4x plus 1. That's so true. I equate it to 0. That's going to be my step number 1. When I equate it to 0, Ella, then I notice that, okay, the next step which I'm doing, essentially the same step, is to solve it. Look at this one. If I take my denominators, and Robert and Lucas, if I put my denominator and equate it to 0, I have essentially built an equation. Then what do you do with an equation?
You solve it.
You solve it. Yes. Oh, no worries. Then if you want to solve it, you take 1 to the other side, it becomes very easy. You get 4x equals to minus 1. Then you isolate x, you get x equals to minus 1 over 4. And that becomes the root, the 0 for this equation.
And then also not in the domain, so that means right.
And give me 1 second, Lucas, please.
Sorry.
No worries. And now, step number 2. In step number 2, what do? I say, I write the D. D stands as a first letter of the domain. I write D. Then I write this one, P of X, a little bit lower, which it says that, for example, Lisa, this is the domain of P of X. Then I'm just going to construct a set. And this set is going to be written like that. We say that X belongs to all the real numbers.
Except for minus 1.
That's so true. Except, however, X is not equal to what?
Minus 1 over 0 over 4.
The root that you got from the initial step.
So you always. Okay.
That's right. You always do this one. That's the strategy that you are going to follow. Take the roots, the denominator is equal to 0. Find the roots, then exclude all the real numbers from it. That's how you find, Sabrina, the domain of the rational expression. Now, my friends, I can see how excited you are about the rational expression. Let me see if I can have that sign also. Guys, please quiet.
I hate him. Oh yeah, wait. Yeah. I got a free sentence. Yeah.
Okay, now,
I say strong.
guys, please everyone, Lucas and Lisa. Now, I just want to ask you, feel that the same method that we use, these two steps, which either, Lisa, the steps that you either see here, or I have done it here, and find the domain of these two rational expressions. just find the domain. Yes.
We did the quadratic equation.
Yes, of course. Use the quadratic expression like a determinant method. Either the factor this or the determinant method. Then find the roots. I'm going to show you now. Guys, I'm just going to do that on the board. You can just help me to just find the solution. Or if you want, you can just do it on your own and check the point I'm asking. Look at this. The first exercise, again, is a rational expression. Because both the numerator and the denominators, they both are polynomials. The first check. The second check is that I'm just going to focus on the denominator. And I say, in order to find the points that this rational expression is not going to be defined, I just take this one to go to 0. Then it means that from here, I have to solve this equation. 2x squared minus 11x plus 5 equal to 0. That's the thing. From now, it's going to be my step number 1. Now, we reduced our problem now to a part that now we have to solve a quadratic equation. Either you have learned this method, either you use the factorization or you use the determinants method. For the determinants method, we said that the roots or the zeros of this function becomes minus b. What is b in this equation? Then minus 11 becomes plus 11. Plus or minus square root of b squared. 11 to the power 2 minus 4 times a, which is 2, times c. How much is c? 5. Divided by 2a, which is 2 times 2. Now, what is going to be the x? X is going to be 11 plus or minus the square root of 11 to the power 2.
121.
121 minus 4 times 2, 8. 8 times 5, 40 minus 40 divided by 4. Then you continue 11 plus or minus 121 minus 40.
81.
7, how much?
81.
81 divided by
Very good, Trevor.
4. How much is this one? Square root of 81. 9. Then 11 plus or minus 9 divided by 4. Then you see that you have 2 roots. Oh, can you see that thing? Then either x is equal to 11 plus 9, which is 20, divided by 4. How much do you get? 20 divided by 4 becomes plus 5. Or x equals to 11 minus 9. 2 divided by 4, 1 over 2. Now, can you see that in order to find the domain, step number 1, we were able to find the roots of that secondary equation. Now, the second step, I'm going to write this one there. I hope everyone can see this because I don't want to read that part. Then I say what? I say D, which stands for domain of P of x, is equal to all the x's, which means that x belongs to all the real numbers, except, however, x does not belong to a subset. You can just write in many different notations either 5 and 1 over 2. There are two subsets. That's how we show the domain of this function when there are more than one root for the denominator. Yes, Jamia?
Is not equal the same thing as not belong, or does it matter?
Now, it doesn't matter. Both of them are correct. I use this one. When you have squeezed E, it means belong, means x all belongs to the real number. However, x does not belong to 5 and 1 over 2. And that's how we define the domain of this function. And guys, look at this one. The roots of the denominator that we were able to localize them, and they are 5 and 1 over 2. We call them also, at the context of the domain, we call them singular points. These points are singular points. I mean either 5 or 1 over 2, we call them, they are the roots of the denominators, which makes the rational expression to look very scary, that you have to run away from this, because when you put them inside, you get the denominator equal to 0. In that context, we call them singular points. Any questions on that exercise? Easy so far, huh? Nice. Now, if you have no questions, please keep this one. A cube. Yes. Sorry, you have a question. Oh, that's cute. My handwriting is a little, I should say, strange. Let me call that Q that way. Q of X.
Is there no, is there, yeah, is it, I mean, that's like, you get a negative number and you can't square root it.
That's the thing we have to discuss. That's a good observation. Then what do we have to do there?
You have to scream and cry.
Then now, if that's the case, you have to scream and run away as fast as you can. Yes. Please, yes, what for?
Like a big before, I don't know how to factor
What do you do
It's not
then?
funny.
Give it a second, then we discuss it together. Now, I'm going to erase this part.
Nothing you can do. It's not part of the part.
You actually not backwards.
You can. No, you can't.
No, because that's not the fine root.
It is not a polynomial. It's just a negative number.
Mr. Daniel.
Yes.
Isn't the Q, the numerator, not a polynomial?
It is indeed.
It is?
That's right.
But I thought it had like something before.
Something like before that we discussed. It is a polynomial because I'm going to explain it. The exponent on the x, which is 1, is a natural number.
So anything with x is a polynomial.
That's right. But provided the exponent is a natural number.
Okay, thank you.
No problem. X, we have also x squared minus 3x plus 12. Okay, guys, look at this one. For this equation also, I give you this polynomial, then the first thing which Kate probably is thinking to do with this is that, oh my god, what is the domain? Lucas, please sit here. Is that, what is the domain of this function? And Matthew is going to say, okay, in order to find the domain, I'm just going to localize and exclude the numerator. And for step 1, I say, okay, I take x squared minus 3x plus 12 goes to become 0. Now, by taking the denominator, that means to go to 0, essentially I built an equation. Now, the question is that, how can I solve it? we say that we say x equals to minus b becomes what? Plus 3 plus or minus square root of b squared becomes how much? 9 minus 4 times ac becomes minus 48 divided by how much? 2a, which is 2. And now, look at this. Look at this one, guys. We have 9 minus 48. How much is that?
Minus 39.
It's, of course, it's something negative.
Which means
And the problem starts here. We have the square root of something which is negative. When you talk about the quadratic, yes, that's correct. All real numbers. Then, as we discussed before, we said that if you have a quadratic function and the determinants, we said that whatever comes under this umbrella, the square root, if it becomes negative, it means that there is what, but there is no roots, no zeros for that function. In that sense, it means that this denominator never becomes 0. Then the q of x, this rational expression, is always valid because there is no one even one single point. You substitute at the denominator, which it turns it to be 0.
what do we say that the domain is there's no domain?
And we say that.
I need numbers.
Look at this. We said that about the domain of qx. And guys, everyone focus please on the board. The domain of all the polynomials, we always assume with us that always it is all the real numbers except the ones that become semi-singular, which makes the denominator 0. Here we do not have a denominator to become 0, then as a result means that the domain, it is always all the real numbers.
My vision is clear.
I'm so glad to hear. Now, any questions?
One question is why.
Is it about gravity?
No, I don't like power.
Why?
It's like I'm hungry.
I thought you ate it.
Then I devour it.
Now, as a last example,
I'll be the last of them.
for this, for the domain,
I'll be up there.
let's do this. It takes maybe 2 seconds, 2 minutes maybe to solve this. We have this polynomial, I'll call that f of x equals x over x squared plus 4. And now, that's your turn, guys. Now, I give you this one. And that's right. And Rodbach says, okay, the first thing I'm going to do with this is that I close my eyes to find the domain of this fractional expression. That's all we need to do. Please do it. Give it a try. Yes. Absolutely, please. Yes.
Here, are we supposed to put in the plus minus? Or no?
It is yes, plus or minus. But remember, we have the square root of something which is minus. Which means that
How do you?
This is again the
All
vote.
real numbers.
Wait, I remember.
this is so true, but it's way too much.
I think I did not.
Now, as what we did before, we'll look at the denominator. The denominator is x squared plus 4 equals to 0. That's an equation right now. And now we are gonna solve it. When you get an equation, what do? You solve it. Then you get x squared equals to minus 4. Wait a minute. How is it possible? We get something goes to the power 2 and it becomes negative. Because it means that x should be something like that. Square root of minus 4. And it's something like this. And we never accept this one because under this root umbrella, all the numbers have to be positive. Then as a result, we say that this equation, which is x squared plus 4 equal to 0, has no solution. There is not even one single point that we can find to plug it for the x to make it equal to 0. If we can find it, let me know, I give you $1,000 cash.
Actually,
It's impossible to find it, then don't worry.
Trick question, Jeff. Come on.
Now, then as a result,
undefined.
the domain of this function, which is f of x, is what? All the real numbers.
What's the difference in P? Like, there's something letters. Like, when you use P after.
It's, for example,
Doesn't matter.
if it's a human being, you call it Steve, you call it Jennifer, you call it Olive, you call it Stephanie, you call it Ramon, Lucas, Lisa.
Okay.
Then that's the Lisa. They can have any names. Now, guys, please listen. You have 1 minute stretch time, or be quiet. Any questions, you know? Daphne, Diana, any questions?
Can we go for like 2 seconds?
Have it 1 minute.
You guys know why? I'm so
Couple yoga exercises are gonna be mad.
How much time do we have?
20 minutes.
1 minute. Let's start.
Yo soy,
Allie. You and this girl.
So is this what the TFS is going to be on?
Yes, you see how easy that? And also inequalities. Inequalities are a little more harder than that. But you have to find something like that. It's gonna be, the second test is gonna be extremely easy.
They're going to include the stuff. Look at the first one or no?
No, just the second part.
It's just the first ever. You went on FaceTime with her.
You have hair?
I don't know why.
No! Why am I?
Yes.
Why am I?
Absolutely.
Why am I?
No problem.
That doesn't work.
Nothing just that I
Everything. Smile, next, you're there. Every session is
You're not. Yeah, he is. I'm not thinking about that. Are you guys reading it? And keep I probably big one.
Okay, guys, now, please take your seats. You have 20 final minutes.
I'll sit down, bro. I'm cool.
Activities.
Actually, I'm actually not
Yeah.
Is this good on computer?
I'm actually born in Toronto.
I was born in Calgary.
Oh my god.
Now, Okay, now we are just getting into the second part of the class. In the first part, we talked about what is a rational expression. We noticed that we can find the ratios of two polynomials and we call it the rational expression. And the only thing which we had to do with the rational expression was that to take the denominator goes to 0, then find the domain. Now, in the second part of the class, we are going to talk about simplifying rational expressions, which is in the fourth page number 4 of your handout. The first page number 4. The page number is at the margin of these pages.
I get it.
Okay, now, guys, look at this. If you have, for example, I'm just going to give you a rational expression, but numerical ones. For example, imagine 50 over, let's say, for example, 20.
3 over 4.
That's right. When you have, guys, please listen. Lucas and Matthew, please. Don't come, please. Lucas. Now, when you have this, what do you do is, guys, now, what do you do is that, what is the key? The key is that you have to write it in the factored form. For example, you say that 15, I can write it as 3 times 5, and for 20, I can write it as 4 times 5. When you are there, you notice that you can cancel out these common factors as long as they are multiplied. The multiplication like this, then you say that as a result, it becomes 3 over 4. Now, I want to expand this method of the simplification and write this one. For example, I have a polynomial which is x squared minus x minus 12 over x squared minus 16. Now, look at this one. Now, I have, again, the same rational expression that we got. The point is that now, when I give you this rational expression, what is going to be the first thing that you're going to do?
Look for the common factors. Common factors, the lowest common.
No. When I give you that thing, this rational expression, the first thing that you do, even before, guys, please listen, it's very important, and especially for your summative test.
Happens to all of us, don't worry.
Now, the first thing that you do, and this is very important, because on the summative test, you may have this one, and if you factor it down, you get the wrong answer. The first thing that you do, without simplifying this expression, like this, the first thing is to do, you find the domain of that rational expression. Do not fall into the trap to simplify this. First of all, you find the domain. What is the domain of this expression?
4.
You say, okay, I'm just going to take
Mental math.
this one here, and I say, look at, please listen. X squared minus 16 equal to 0. That's the first step. Now, then I say, okay, that's an equation which I have to solve it. Then I say x squared equals to 16. Now, you are going to solve it again. How much is the x?
4.
Sorry. X is plus and minus 4.
You're wrong.
Why?
But it's still.
Why? Because guys, look at this. We talked that before. We said that if you have an equation like this, guys, I can hear what you're talking. Please, guys. Please, everyone, look. Oh. We say that if we have an equation like this, x squared equals to a here is 16. Then when you solve it, x is plus or minus square root of a. Because of this identity, when I solve this equation, I got plus and minus 4, not only 4. Then as a result, the domain of this function, the domain of p of let me just write it here. The domain of p of x, then as a result, is going to be all the real numbers. However, x does not belong to plus 4. Let me write it like that. X cannot be plus or minus 4. We can also write it x equal, x should not be equal to plus or minus 4.
I understand.
One method. Now, then you see the first thing which I did was to find the domain without doing anything. Without doing anything, we start with the domain. Now that we have the domain, I'm just gonna, how much time do I have? 20 minutes, huh?
Not sure 30.
Okay.
I'll say for that.
Okay, now, look at this. Now, Sabrina, the first thing that I did was that find the domain. The second thing which I'm going to do, I'm going to try if I can simplify this rational expression. Simplification of the rational expression is going to be a huge part of your summative test. Then please listen and look what I'm going to do. First of all, after we find the domain, I'm going to factor, if possibly I can, not all the time it's possible, to factor both the numerator and the denominator. Now, for factoring the denominator, we can think of one identity. I'm going to write this one here. This identity is this. We call that the conjugate. You have learned that in the prior years. We said that if a minus b is multiplied to a plus b, for example, x minus 4 times x plus 4, then normally what do you do when you just want to find the answer for this? What do you do? Normally you say, oh, wait a minute, let's do this one by one. Let's multiply a to a, multiply a to b. Then, oh my god, too much work. Then b minus 2 is, that's right, this one. When we have this expression, we do not need to just do that. I say I'm not going to do this. I hate working a lot on these kind of simplifications. Then simply I say, okay, it becomes the first term, which is a squared, minus the second term, which is b squared. They call that conjugate identity. Then if I look at this one, the denominator, I can see that this is minus between two terms that they are raised to the power 2. Then I say, okay, how about if I rewrite this as x squared minus 4 to the power 2? If that's going to be the case, imagine now, x squared minus 16, I write it x squared minus 4 to the power 2. It's exactly like this. Then I can write x minus 4 times x plus 4. Alright? Now, I'm just going to write this one. X minus 4 times x plus 4. Now, the factorizations of the denominator is now done. Now, I look at this term. The second term, the numerator, it seems I have only 5 minutes left. Oh, good. 1 minute is going to be very helpful. Thanks. Now, I can remind myself of this method. I say I have two binomials, A plus B, which is multiplied to A plus C. Look at this. These two terms have these two expressions, have two terms which they are the same. A is the same, is shared between these two. Then when you multiply them, you do not need to just come here and say this times this times this. You say the common term is a square, plus you add the terms that they are different between them, which is B plus C, times the term which is common, plus the product of the terms which they are not the same, they are not common. This is the same thing as what we have seen. I say I use this identity because I don't want to expand this term times this plus this term times this, again this term, too much work. Then if I see two terms, they are multiplied, and there is one term which is shared between them, I square the term which is shared. A is the same, I square it. B and C, they are different. I sum them, multiply to the term which is equal, the same, plus B times C. If that's going to be the case, I'm going to try it on this. How to do that? I open parentheses. The first term, which is x squared, it means that it can be the common term because a squared is for the common term. Then I put x and I put x there. Now, this is -1 there. This -1 means that you have two numbers. They were added together. They become -1, but their multiplication is -12. Find two numbers that when you add them becomes -1. When you multiply them becomes -12. 4 and 3, that's a good option. 4 times 3 becomes 12. Good. But when you add them, you get -1.
-4 and 3.
That's right. -4 and 3. And now it's factored. Look at that. X squared minus x minus 4 times 3 becomes 12. Now, let's have a question. Now, within the last 2 minutes that you have, look at this two expressions. X minus 4, x minus 4, x minus 4. These two terms are common. Then I cancel them out. Then it raises to what? X plus 3 and x plus 4. This is a simplified version. Any questions, guys? Because I'm going to tell you the most important thing of the day. And it's crucial for the summative test. Look at this. Compare the polynomial after simplification with the polynomial before simplification. What is the domain of this one? Say the domain. It's only -4 because you say x plus 4 equal to 0, then there is only one root, which is -1. Which means that the domain is x, all the real numbers, however, x is not -4.
Or -3?
Huh?
Do you write or -3 because of the top?
No, just the denominator. Just the denominator. And guys, look at this. I finished today by this. Compare this domain. X should not be equal to -4. With this one, that x should not be equal to plus and minus 4. That's right. You see that 1, 0 is missing over there, then you say that this domain is not correct. Then that's right. That's why I told you. Guys, everyone listen. Very quiet. It's very important, the most important thing of today. That's the reason I told you, when you have a rational expression, when you want to find the domain, do not simplify this. First, find the domain, then go to simplify this. Because if you do that, you see that the domain is missing one singular point. Then the strategy, find the domain before simplification, then simplify.
But how is that wrong?
It is correct, but if you are looking at this one of them is missing. You also need plus here. You do not have plus for it. Then it means that before you simplify, you find the domain.
Okay.
Guys, I'm gonna post some homework. Oh my God, what is the attendance? Oh my God.
Where's Lala? Is my homework for tomorrow? I can walk in here.
Tomorrow, no, it's gonna be for the day after tomorrow, not for tomorrow. We continue tomorrow, but the homework is gonna be at the end of the week. Okay, take it easy. No problem.